Hello friend, now we will discuss about the simultaneous equation method calculation part. Now let's see the one by one how to find out the unknown concentration by the help of the simultaneous equation method. Now we will discuss about the principle of the simultaneous equation method. If a sample contains two absorbing drugs, that is a X and the Y, the each of which absorb at a different lambda max, that is a lambda 1 and lambda 2. It may be possible to determine both the drug by the help of the simultaneous equation method. Now consider a multi-component system or a mixture of the component consists of a two component drug, that is a component X as a drug X and the component Y, that is a drug Y. Lambda 1 is equal to wavelength of maximum absorbance of a drug X and lambda 2 wavelength is a maximum absorbance for a drug Y. And the same, the AX1 and AX2 absorptivity of X at lambda 1 and lambda 2 respectively, and same for the drug Y. As you can see in the graph, that is a absorbance of a different drug, that is a drug X and the Y, it absorbs other different lambda. For the drug X is absorbed at 250 nanometer and the drug Y is absorbed at a 300 nanometer respectively. From that we can calculate the unknown concentration of both the drug by the help of the simultaneous equation method. Now let's see the how to calculate. The absorptivity of the drug X at lambda 1 and lambda 2, that is a AX1 and AX2. For this same, the drug Y, the absorptivity of Y at lambda 1 and lambda 2, that is a AY1 and AY2. From that, the Cx and the Cy is the concentration of the drug X and the Y respectively. In the sample or a mixture of the formulation is occur, and the absorbance of the diluted sample of X at lambda 1, that is a AX1, and for the lambda 2, that is AX2, and for the drug Y is AY1 and AY2. For the component of the A is A1 is equal to absorbance of a mixture of drug A and Y at lambda 1, and for the A2 is the absorbance of a mixture of X and Y at lambda 2. So therefore the A1 is equal to absorbance of X at lambda 1, that is AX1, plus absorbance of the Y at lambda 1, that is AY1. Therefore the given equation is formed, the A1 is equal to AX1 plus AY1, and the AY1 is the absorbance of the drug Y at lambda 1, that is AY1. By the applying the Lambert's-Beer's law, that is AX1 and AY1 can be calculated as a given equation. Now putting the value of AX1 and AY1 from the equation 2 and 3 in a equation first. Now as you can see, now from that we form the equation number 4. Now the similarly for the drug, that is A2 is equal to absorbance of a mixture of the X and the Y at lambda 2, and therefore the A2 is equal to absorbance of X at lambda 2, that is AX2, plus absorbance of the Y at lambda 2, that is AY2. Therefore the equation form is A2 is equal to AX2 plus AY2, that is AY2 is nothing but absorbance of Y at lambda 2, that is AY2. Now same for the applying the Beer-Lambert law, that is the AX2 and the AY2 can be calculated by the given equation. Now the putting the value of ax2 and ay2 from the equation 6 and 7 in equation number 5. As you can see, and from that the equation 8 is a form. Now the rearranging the equation number 4 for a calculation of the cy. Let's see how to rearrange the equation. The a1 minus ax1 into cx and is divided by the ay1 and into cy. Now the calculation of the cy concentration is equal to the a1 minus ax1 into cx divided by ay1. Now putting the above value of the cy in the previous equation, as you know the equation number 8, that is a2 is equal to ax2 into cx plus ay2 into cy, that is the equation number 8 as you can see in the previous equation. Now let's put the equation number 4 into the equation number 8, that is a1 minus ax1 into c divided by ay1. Now solving the above equation, as you can see the how to rearrange the equation number 4 from the calculation of the concentration of the cy. Now making the common LCM of the ay1 in the previous equation, that is a2 is equal to ax2 into cx plus ay2 into a1 minus ay2 into ax1 into cx. Now take a LCM of the ay1 is, now can see, now the solving the above equation, that will be the form in the a2 is equal to ay1 into ax2 into cx divided by ay1 plus ay2 into a1 minus ay2 into ax1 into cx divided by ay1. Now sorting out the for the cx the common of the RHS and adding into the a2, and we form the equation as you can see. Now continue. Rearranging the previous equation from the cx, as you know we find out the a2 is equal to cx into ay1 into ax2 minus ay2 into ax1 plus ay2 into a1 and divided by ay1. Now we again rearranging the equation for the calculation of the cx. Now let's see how to rearrange the equation. As you can see, in the denominator form, that is the ay1 minus ay2 and the a1, it shifted to the left hand side and it will be the form a2 into ay1 minus ay2 into a1 divided by the ay1 into ax2 minus ay2 into ax1, and from that we can calculate the cx. That is a cx is as you know the unknown concentration of the drug, that is a x. For the similar derivation for the cy can be the performed by the using the above value, that is a cx in the previous equation number, that is a 4, and further you can calculate the equation for the cy. Thank you.